You've probably heard the term microservices thrown around a lot lately. It's kind of become the new normal in software. But what does it actually mean? Well, today we're going to demystify it all. We'll break down what it is, why you should care, and how the whole thing hangs together.
But before we dive in, let me ask you something. Think about the apps you rely on every single day. They're getting more complex, right? And we expect them to be available 24/7, no excuses. So is the old way of building software, is it really cut out for that future? Let's dig in and see.
To really get the new way, we gotta look at the old way first. The classic approach is what we call a monolith. Honestly, the best way to think about it is like one of those giant, all-in-one kitchen appliances from an infomercial. You know the one? It juices, it blends, it toasts, but what happens if the toaster part breaks? The whole thing grinds to a halt. Now, microservices, totally different mindset. Picture a modern kitchen. You've got your toaster, your blender, your coffee maker, all separate gadgets. If the toaster goes on the fritz, hey, no big deal. You can still make a killer smoothie. That is the fundamental difference.
Okay, so let's put a pin in that analogy and get to a real definition. A microservices architecture is basically an approach where you build one big application out of a bunch of tiny, independent services. Each little service has exactly one job to do. And the cool part is, you can build it, update it, and even scale it up or down all by itself, without messing with anything else.
So you might be thinking, okay, that sounds complicated. Why would anyone go through all that trouble just to break things up? And that's a great question. So let's talk about the why. What are the actual real-world benefits?
Well, it turns out the benefits are huge, and they solve some of the biggest headaches in software development. For starters, maintenance gets so much easier. You're not hunting for a bug in a million lines of code anymore. Instead, you're looking inside one small, focused service. This also means different teams can work on their own pieces at their own pace, which is a massive productivity boost. And remember our kitchen? You get that amazing fault tolerance. If your payment service has a hiccup, it won't crash the entire online store. And finally, you get this really clean alignment with the business. The shipping team owns the shipping service. Simple as that.
But here's the catch. You can't just stumble into this. Building with microservices demands a whole new way of thinking. It's all about architecting for independence right from the get-go. And that whole philosophy really boils down to 3 core principles.
And this quote right here, it just nails the first principle. The goal isn't to just chop up your code into random small bits. No, the real art is in finding the natural seams in your business. Think about it. Customer accounts are different from inventory management, right? So you draw a line between them and build a digital wall, an API, to protect that boundary.
And that leads us to what we call domain boundaries. The idea is simple. You structure each service around a specific business function. So, for an e-commerce site, you'd have a user account service, an inventory service, and a payment service. Each one is its own mini application, and the only way they're allowed to talk to each other is through those official channels, their APIs.
Now, the second principle is a big one, and it's super strict: exclusive data ownership. This means the inventory service, and only the inventory service, is allowed to touch the inventory database. If the payment service needs to check if something's in stock, it can't just sneak a peek at the data. Nope, it has to formally ask the inventory service. This rule is what prevents everything from turning into a giant tangled mess.
And that brings us to principle number 3, isolation. This one is all about the technical side of things. You deploy each service in its own little bubble, a container, or maybe even its own server. Why? So they don't fight over resources like memory. But even more importantly, this contains any damage. If one service has a bug and crashes, it crashes alone. It won't take the rest of the system down with it.
All right, so principles are great in theory, but let's make this real. How does this all actually work in practice? Let's walk through a pretty common example, a reservation system.
So, imagine you're trying to book something. Your request first hits the reservation service. But here's the thing, that service doesn't have all the answers. It has to act like a coordinator. First, it pings the resource service and asks, hey, is this room even available? Then, it turns around and asks the channel partner service, is this partner's calendar free? It's only after it gets a yes from everyone involved that it can finally confirm your booking. You see how they're all working together, but none of them are stepping on each other's toes?
Now you might be wondering, how do all these services chat with each other so fast? They need to be quick. While they could use standard web APIs for that super fast internal chatter, a lot of systems use something called gRPC. Just think of it like a secret high-speed language that only the microservices understand.
It's way more efficient and perfect for situations where every millisecond counts. Okay, so when you have all these little services running independently, you've officially created what's called a distributed system. And, well, managing a distributed system comes with its own unique set of puzzles to solve. You're going to need a special toolkit.
Yeah, these microservices don't just exist in a vacuum. They don't magically coordinate when you have thousands of users hitting your app. To get them to work together reliably at scale, you really need a whole ecosystem of powerful tools to handle everything.
First up is something called load balancing. Let's say your reservations service suddenly gets super popular. You can't just have one copy running. It'll crash. So you run a bunch of identical copies. The load balancer is like the friendly traffic cop out front, directing incoming requests to all the different copies so that no single one gets swamped.
Then there's caching. Imagine everybody's trying to book the same hot ticket item. Instead of hammering your database with the same question over and over again, is it available? Is it available? You can just store the answer in a super fast, temporary storage space called a cache. The next person who asks gets the answer instantly, and your database gets a much-needed break.
But what happens when one service needs to send a message to another, but it's not urgent? It doesn't need an answer right away. That's a perfect job for a message queue. It's like a digital mailbox. The first service drops off a letter, and the second service picks it up whenever it has a free moment. This is amazing for resilience, because if the receiving service is down for a bit, the message just waits patiently for it to come back online.
And finally, the magic that holds all of this together, containerization. You've probably heard of tools like Docker. What it does is package each little microservice into its own neat, tidy, portable box. Then, a tool like Kubernetes comes in and acts as the master orchestrator, managing thousands of these boxes for you, telling them when to start, when to stop, and how to talk to each other. It's this one-two punch that makes microservices actually practical in the real world.
Okay, we've gone through the core ideas, a real-world example, and the tools that make it all happen. So let's zoom out. What's the big takeaway here?
Here's the bottom line. Microservices give you incredible power. We're talking flexibility, resilience, and the ability to scale in ways that are just really, really hard with a big old monolith. But, and this is a big but, it doesn't come for free. It forces you to completely rethink how you design software, how your teams communicate, and how you operate everything.
And that leads us to one final thought to leave you with. Moving to microservices isn't just about changing your code, it's about changing your organization. You're essentially trading one kind of complexity, a complex codebase, for another, a complex system of interconnected parts. So the real question isn't just, can we build this? It's, are we ready to manage this? Are we ready for the responsibility that comes with all this power? That's the challenge. Thanks for joining me.